Hi guys, welcome back. Today we're going to be solving trig equations. In order to get started with those trig equations, let's talk about the steps that it takes. So our first step here says get the trig function by itself and to the first power. So we're going to want to isolate that trig function, and it has to be in the first power. So that means you might have to factor. That may be taking out a GCF. That might be a trinomial a equals 1 or a not equal to 1, or by grouping or something of the fashion. You might have to take the square root. So if it's a squared trig function, you're going to want to take the square root. And don't forget that when you're taking the square root of a square, you need the plus or minus. Step 2, if the trig function is cosecant or secant, you're going to want to change it to sine or cosine because that makes it easier to work. Step 3, you are going to then use the unit circle to find the angles that work. I told you guys you have to know that unit circle really well. So now you're going to need to use that unit circle to find the angles that work with your equation to solve. When you're doing that, you want to make sure that you read the directions on the question, because in some cases you'll have to answer in radians, and in some cases you'll have to answer in degrees. And then your final, to check your work, you would be checking it by plugging it into the original equation to see if it works. All right, now we're going to do some examples so you can see how that works. So we've got secant of theta minus 2 equals 0. Now the directions are not written here, so we do want to talk about something. We're going to work this between 0 and 2 pi in radians and 0 and 360 degrees in degrees. So if they asked in radians, we would be working this from 0 to 2 pi. And then if they asked in degrees, it would be 0 to 360. That's one full circle of the unit circle. All right, so we've got secant of theta minus 2 equals 0. So the first thing I'm going to do is I'm going to add the 2 to get it to the other side. So we get the secant of theta is equal to 2. My next step is going to be, now that I've got it isolated, I want to convert this to a sine or cosine. And secant is the reciprocal of cosine. Secant is 1 over cosine. And so to get it to be cosine, I could cross multiply. You can think about that way, or you can do the reciprocal. So the cosine of theta is equal to 1/2. So what we're going to do now is use the unit circle. So we isolated the trig function, we've converted it from a secant to a cosine. Now we're ready to use that unit circle. And I'm going to do both radians and degrees here. Before I do that, let's check our unit circle here. So the point cosine of theta is equal to 1/2. We know cosine is our x value. So we're looking for where our x value is 1/2. Notice that that's positive. So that means that these two quadrants are really going to be taken out of the equation. The only ones that are going to be found are over here, because that's where we have a positive x value. And we want the ones that have an x value of 1/2. And so if I was talking in radians, the first one that has 1/2 is pi over 3. If we're talking in degrees, that is 60 degrees. That's what in the first quadrant. If we want the one that has 1/2 in our fourth quadrant, well, that's 5 pi over 3, or 300 degrees. So that's what you're doing. You're thinking about that unit circle backwards, which one has the x value of 1/2 to get the radians or degrees. All right, so we're going to try another one over here. We've got tangent squared of theta minus 1. I'm going to go ahead and add that 1 to get it to the other side. So I get tangent squared of theta is equal to 1. Now we need to get rid of this square. So this is where we take the square root to get it to a power of 1. And so we get the tangent of theta, because the square root and the square cancel. And now I need that plus or minus, because anytime you're taking the square root of a square, a negative times a negative also gives you a positive. So you got to think about the plus and the minus. And the square root of 1 is 1. All right, so if we think about our tangent, that is y over x. And so we want y over x to be 1. The only way that y over x is going to be 1 is if y and x are exactly the same thing. So we want to think through our unit circle there, and the only time that they're the same is when it's square root of 2 over 2 and square root of 2 over 2. And so this is going to be in all four quadrants since it is plus or minus. We're looking at the positive ones and the negatives. So this is going to have four solutions. It's going to have pi over 4, my first quadrant, 3 pi over 4 in my second quadrant, 5 pi over 4 in my third quadrant, and 7 pi over 4 in my fourth quadrant. Again, we were looking for that one that has the square root of 2 over 2, because that's where y and x are the same. If we did that in degrees, that would be 45 degrees, 135, 225, and 315. In most cases in calculus, you're going to be talking in radians, but we are going to go ahead and show you both here. All right, so let's keep going with this. On our next example, we've got 4 sine squared of theta minus 3. I add the 3 to get it to the other side. And then I divide by 4. So we've isolated our trig function here to be sine squared of theta is equal to 3 over 4. It's time to get rid of that square. So we're going to take that square root and the square cancel, so we get sine of theta is equal to, the square root of 3 does not simplify, but the square root of 4 does. The square root of 4 is 2. So we've got sine of theta is equal to the square root of 3 over 2. We're thinking about our unit circle again. So we want it to be the point where our y value, because sine is y, so we're looking for where our y value is the square root of 3 over 2. So over here, we were looking for where y was equal to 1/2. Here we were looking for where x and y were the same thing. For C, we're looking for where y is the square root of 3 over 2, and that is plus or minus. I almost forgot that plus or minus. Make sure you've got that there. Since it is plus or minus, then again, we're going to be in all four quadrants since we've got the plus and the minus. So we're going to have four solutions again. So in my first quadrant, the y value at square root of 3 over 2 is at pi over 3. In my second quadrant, that's 2 pi over 3. In my third and fourth quadrant, that's where we're going to find the negative root 3 over 2, which is going to be 4 pi over 3 and 5 pi over 3. We'll go ahead and write the degree ones of that. It's the same values as those radians, just in degree. All right, so for our next example here, we're going to add 2 to get it to the other side. So we get cosecant squared of theta is equal to 2. Now we're ready to take that square root. So we're going to take the square root of both sides. And so that gives us the cosecant of theta is equal to plus or minus root 2. That doesn't simplify very well. And so we know that the reciprocal of cosecant is sine of theta. And the reciprocal of this would be the plus or minus root 2 over 2. When we do the reciprocal, just as a little side note here, that would give us this 1 over root 2. But remember, we don't leave the root 2 in the denominator, so we need to rationalize. So we multiply times root 2 over root 2, and that's where we get that root 2 over 2. So we're looking for sine of theta, where it gives us plus or minus root 2 over 2. Again, we're going to end up with 4 solutions because this does have the positive and the negative. And so we're going to find everywhere the y value is root 2 over 2, whether positive or negative. So we'll start with the radians again. That's pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4, and then our degrees, same exact ones, just in degree mode would be 45, 135, 225, and 315. So get used to knowing that unit circle really well so that you can work forward and backwards. You can get the cosine ratios, the sine ratios, the tangent ratios, and so on, and you can get the angles. That's what we're looking for here. We are going to continue, and I'm going to show you a couple more examples on this one right here. We've got a squared cosine and a power to the first power cosine. So we're going to want to get that set equal to 0. So I'm going to subtract that cosine to bring it to the other side, and I get cosine squared of x minus cosine of x is equal to 0. I've taken everything to one side of the equal sign so that I'm able to factor. So I can factor out a cosine x here. That's my greatest common factor. Cosine x times cosine x gives me that cosine squared, and cosine x times -1 gives me that negative cosine x. We know back from quadratics that when we're solving by factoring, we set each one equal to 0. So I'm going to set each one of my factors equal to 0. So I'm looking for when cosine of x is equal to 0. And I'm looking for where cosine of x minus 1 equals 0. The left-hand side is the easier one, so I'll go ahead and do that one real quick. Cosine of x is 0. We're looking for where the x value is 0 because cosine is x. And that would be at our 90 and 270. Or if we did that in radians, that's going to be pi over 2 and 3 pi over 2. Now, when we solve this one, I'm going to add the 1. So I get a cosine of x is equal to 1. We are looking for where the cosine is 1. So that's the x value. And so we know that happens when it is at 0. And then when it returns to 2 pi. We're not looking at the 180 because that would be -1, and we only want to know where it is a positive 1. And so if we did that in degrees, that would be 0 degrees and 360 degrees. All right, for our next one, we've got a trinomial because it does have 3 terms here. And so just like we did with quadratics, we're going to want to factor cosecant x squared. That comes from the cosecant x times cosecant x. And then we're looking for what multiplies to be -2 and adds to be 1. Notice that is the same way that we factored a quadratic. So looking for what multiplies to be -2, adds to be 1. And that is a +2 and a -1. Again, just like the other one, we would want to set each factor equal to 0. So we're going to take cosecant x plus 2 is equal to 0, and cosecant x minus 1 equals 0. I'll solve each one separately, so I'm going to subtract that 2. I'm going to change it from that cosecant to sine, and when I do that, we're looking for the reciprocal, so that would be -1/2. We're looking for where the y value is -1/2, so we know that's going to be in the 3rd and the 4th quadrant. In the 1st and the 2nd, the sine value is positive, so we know it's not going to be those. And so in the 3rd quadrant, that would be 7 pi over 6. And in the 4th quadrant, that would be 11 pi over 6. Oops. That's 210 and 330. For our other one here, we're going to go ahead and add the 1 to get it to the other side. I convert it to my sine, and then I'm going to flip this. Well, flipping 1 is just still 1, so that doesn't change much. Now we're looking for where sine is 1, and that only occurs at the 90 degrees, because at 270, it would be at -1. So x here is going to be at pi over 2, or the 90 degrees. In most cases, you're going to see that written in the order, numerical order, so that would be 7 pi over 2, 7 pi over 6, and 11 pi over 6 if you were to write it correctly. All right, we got some more examples here. If you think you're ready to go ahead and try and solve some, go ahead and pause, try it, and then check your work. So we've got 2 secant squared x plus secant x minus 1 is equal to 0. That is a trinomial. Some people rather see this as a quadratic, so you could factor it that way first. So that's 2x squared plus x minus 1. Go ahead and factor that with the box or slide and divide or X or cab or whatever method you use to factor. That's what you're going to do here when the A value is 1. So you can't do this one, what multiplies to be the last one and adds to be the middle one, because it does have this 2 in the front here. So we would go ahead and factor. These two same factors are the ones that you would use here. So this is going to factor to be 2 secant x minus 1, just like this part right here, and then secant x plus 1. So if you would rather factor the quadratic first and then set it back up as a trig function, you can do that. Now we go ahead and set this equal to 0. And we set the other factor equal to 0. And then we're going to solve each one individually. I would add the 1 to get it to the other side, and I get 2 secant x equals 1, and then I divide by 2. So we get secant x is equal to 1/2. Now, if I go ahead and convert that to cosine, which is the reciprocal, so secant converts to cosine, and that's the reciprocal. So we get cosine x equals 2. Well, we know that there's no x value on the unit circle that's 2. That's outside of our range and our domain. So we're going to, that one doesn't exist. That's a no solution there. So we write DNE, which means does not exist. Now, that doesn't necessarily mean there's not a solution. We would still have to solve this one. So we get secant x equals -1. And so I convert that to my cosine, and when I flip this, it's still -1. And so we're looking for where the x value is -1. Well, the x value is -1 at pi, or 180. So that would be our solution. Just because one of the factors didn't have a solution doesn't mean the whole thing doesn't have a solution. This one did not work out, but this one did. All right, for our next one here, it only has 2 terms, so I would want to factor out my cotangent x. And when I factor that out, cotangent x times cotangent x gives us cotangent squared. And cotangent times 1 gives us that cotangent x. I take each one of these and I set them equal to 0. And this one is commonly missed. This one out here, for some reason, students don't list that one equal to 0, but both of these are factors, so they both have to be set equal to 0. Now, if we think about cotangent x equal to 0, cotangent is our x value over our y value. So x over y, we want that to be 0. So we know we want the x value to be 0. And so our x value at 0 is pi over 2 and 3 pi over 2. For this one here, we're going to subtract the 1. And in this case, we want the cotangent to be -1. Again, that's x over y, and we want that to be -1. So we know that the x and the y both have to be the same. And one of them has to be positive, one of them has to be negative for it to come out to be a -1. Well, the only ones that are the same are the square root of 2 over 2 and square root of 2 over 2. And so that's going to happen where there are different signs. That's going to happen in the second and the fourth quadrant. That's the only way it's going to give me that negative there. And so that would be 3 pi over 4 and 7 pi over 4. Took a little more thought to get through that one, but you should be able to make sure that you're being careful with those details so that you get that. All right, so on this next one, we've got 3 tangent squared x minus 1. We would add the 1, and so that gives us 3 tangent squared x is equal to 1. I divide by the 3, and we get tangent squared of x is equal to 1/3. That's when we take our square root. And since we're taking the square root of a square, we need the plus or minus. Now the square root of 1 is 1. The square root of 3 does not simplify. And so we've got 1 over the square root of 3. To remind you, the y, a tangent is y over x. So that means that here our y value had to be 1/2 and our x value had to be the square root of 3/2. So that gives us the point square root of 3/2 and 1/2. That's the point we're looking for on the unit circle. So you do have to make that thought process go through your head. How did we get to tangent? Tangent's y over x. How did we get a 1 and a square root here? Well, that's going to be the 1/2 and the root 3/2. Make sure you're thinking that way. And so the point that gives us square root of 3/2 for the x and 1/2 for the y is pi over 6. This is plus or minus, so I would also need the -1. That would be at 5 pi over 6, then 7 pi over 6, and 11 pi over 6. Again, this one has 4 because we are taking that plus or minus one. All right, if you haven't put it on pause yet and tried one, this is a good time to do it since this is our last one. Again, we've got a trinomial and it does have an a value of 2. So you can go ahead and set it off to the side as a quadratic and do 2x squared minus x minus 1. And factor that. That factors to be 2x plus 1 and x minus 1. So when we set this up, that is 2 sine x plus 1 and sine x minus 1. Now we set each one equal to 0. I'm going to subtract the 1 and divide by 2. I'm looking for where our y value is -1/2. Since it is negative, I know that's going to be in the 3rd and 4th quadrant. That's where our y values are negative. So you do have to be careful with all of those details. And so that is 7 pi over 6 and 11 pi over 6. For this side here, we add the 1. And so we've got the sine of x is equal to 1. There's only one place where the y value is 1, and that is at our 90 degrees or pi over 2. So now we've done a bunch of different examples. Make sure that you do your practice so that you get used to working forward and backwards with these on the unit circle.